Okay, welcome back, class. Let's talk about our next topic, which is nested loop and multi-dimensional arrays. We're going to start with a multi-dimensional arrays, and what I mean by that, well, to talk about a multi-dimensional array, let's first talk about a one-dimensional array, and let's recap that. So when we talk about a one-dimensional array, as we've seen before, we're really talking about like a list, or you could also think of it as a vector, right? You've got a single list or vector of numbers or whatever the data type is, right? So you've got whatever information you're deciding to store here, whether it's an array of integers or maybe it's in the context of a string. It could be an array of characters. And so that's our one-dimensional array, right? So if we're looking at it in the kind of, like I mentioned before, we can think of it as a vector, okay? As a vector, if we're looking at it as numbers, right? But there's other times that we want to store different information, which is more in a like table format or a matrix. So if we look at the context of something like a two-dimensional array, what we're doing in this case is we're looking at, instead of just a single list of information, we're effectively building something like a table or a matrix where we have a whole bunch of information being stored this way, whatever it happens to be. So we have some of our rows and columns. And we could have this in a multi-dimensional space. It doesn't just have to be a table. We could have three-dimensional arrays. And so you can have, more coordinates to be able to justify that, right? To be able to define that. So to define a one-dimensional array, we can come back to the one-dimensional array scenario. We look at how we declare that. We would do something like, again, if it was an integer array, we would do something like this. Right, we're then going to specify here whatever the size is, okay, whatever the size is, and it's going to work in a similar way for multi-dimensional arrays. And we'll look, particularly, let's look at a two-dimensional array, right? We would say we have to specify the size of the rows and the columns, right? So we need two numbers. Okay, to specify the number of rows as well as the number of columns. Okay, so it's a similar idea, and we could also expand this. We could do a three-dimensional array, right? Where then you have basically, if you think of two-dimensional arrays being like a matrix, right, or like pixels on a screen, like on a flat surface. For three-dimensional, it'd be like voxels, right? You have a three-dimensional space, and you're specifying a coordinate, like a block, a cell in that three-dimensional space, and you could do that as well. Okay, so this is how we can declare an array with name A. It's a two-dimensional array. Okay, and if we look at this, right, if we're trying to access a particular cell in a two-dimensional array, we're going to use the same kind of square bracket notation, just like we did with the one-dimensional arrays, except now we need to have two coordinates, right? Because you have a row and a column that you need to define. So, for instance, if we wanted to be on row 2, column 1, right, we're going to get that value as a square bracket 2, square bracket 1. So in this case, if this was our array here, that would have A 2 1 would have value 6. Okay, so again, it's a table, effectively table or matrix. That's all it is. Okay, and obviously, just like you would in Excel or something, if you're going to get at a particular cell in a table, you need to know the row and the column. Okay, so it's a simple idea as that. Just as a minor thing to kind of point out, storing a two-dimensional array, how that's actually stored in your computer's memory is that it's still stored really like a one-dimensional array. You've got the sequence of numbers being stored sequentially in memory, in your computer's memory. What I mean by sequentially is that as you move from one location to the next, right, you're going to another location in the same array. So we can see is what we're really doing here, right, is that we have this as a row, and then we have the next row in the array, the next row in the array, and so on. Okay, so that all the information is still stored all right next to each other in memory, right? And so that's kind of that has some implications as you kind of get deeper into programming and understand how things are stored and used and different memory regions, and we'll hit some of that in this class. Okay, so just a couple minor things to point out in terms of when we look at initializing arrays. In the one-dimensional case, right? In the one-dimensional case, we saw different ways that we can initialize it. Okay, and one of the ways that we can initialize it is to do something like this. Okay, and I have an array. I'm just, in this case, of size 4, and it's actually optional whether or not to put the size in there in that case. If I put 4 here, that's completely valid. I actually don't have to, because the compiler is going to be able to know that this is indeed needs to be declared as size 4 based on the number of elements that are here. But that's a valid way of declaring it. So we saw that. Okay. Now I'm reminding you of that because we could do something very similar in the case of a 2D array. Okay. Except I need both of these square brackets. This is indicating that it is indeed, this is telling the compiler the number of dimensions, right? The dimensionality of it. Okay. So that's informing the compiler the number of dimensions. And really what a two-dimensional array is an array of arrays. Okay, it might seem a little weird, but it makes sense, right? If you look at a table, what is a table effectively, right? A table here is an array, right, of arrays. So if we had this would be like a one-dimensional array is just that one row, and then we'd have another array of another row, etc. So you can see how it's in a sense you're almost like this like nesting view or this hierarchy that's formed. So if I did something like along these lines, okay, this is a completely valid way to initialize an array, okay, a two-dimensional array. And what that's going to do, right, is that's going to form an array that's going to look like this, okay, where we have our 2 columns and 3 rows. We have our array here, okay, and then the next one, and then the next one, okay. So we have this two-dimensional array, and once again, right, if I wanted, let me just pick a location as an example, right? If I wanted to find this location here that's storing value 3, okay, that's going to be indexed by location. It's row 1, right? Row 1, column 0, okay? Excuse me. It's not the coronavirus, I swear. Okay, so that here is going to give us value 3. Okay. So, it's nice to have that visual reference. Okay. Now, just a little bit of practice, right? This just shows something kind of similar. Imagine we've got a 2D array declared of size 2, 3. Okay, so in this case, it's 2 rows, 3 columns. A little bit different. It's kind of the transpose of it, or it's flipped around the other way. And the one that we just looked at, And what we're doing here is we're saying if we had that declared, and then we went 0, 0 to value 55, 1, 1, 77, 1, 2, 99, right? And then we wouldn't know these have not been initialized yet in these other cells. Okay. I'm just kind of getting a sense of how what we're effectively doing is looking at how we address things, right? How do we get at the different cells for a 2D array? And it's the same idea for if you went to 3 dimensions, you would just have an additional square bracket here. Okay. Now we looked at how we can initialize things this way. Remember, this notation only works when we're going to do these curly brackets to initialize it this way, only when we're declaring the array. Once it's declared, and if you're trying to change the values or initialize it a different way, you've got to do something different. Okay. Okay, so let's look at how another way we can kind of initialize an array. Okay. Excuse me. So another way we can initialize an array is to use something called a nested loop. Nested loop. Well, what I mean by a nested loop is that we have a loop inside of another loop. Okay, a loop inside of another loop, and this tends to be a very helpful way of organizing using two-dimensional arrays. Because effectively, we really what we want to do, like imagine we declare. Let's imagine we've got a an array that we've declared as this. Okay. So, well, what does that mean, right? That means we've got 3 rows and 4 columns. Okay. And let's imagine we want to initialize this such that we're just going to write in here something along the following lines. Okay. I'm doing that just so we just write something into the table. Okay, something in there. We'll look at more interesting examples where we have something kind of useful and meaningful a little bit later on. So how would we do this? Well, the easiest way to do this conceptually is to have one loop, right, that I'll call, I'll actually give it the name row, right, a variable row, that iterates from 0 down to 2, okay, and another variable column that goes from 0 over to and counts up to 3. Okay, so how do I want to accomplish this? Well, let's start simple. Let's just think about, well, what if we just only cared about the one row? What if we just cared about initially of doing something like this, and we're going to expand it? We're going to say, well, imagine we just had one row, and we had a one-dimensional array, right? And we wanted that to that array to do the following, right? We wanted that array to store the following information. Okay. Well, how could we do that? And I'm going to go to the environment and code it up for real so we could see this. All right. I'm going to go ahead and declare an array. And I'm going to start as a one-dimensional array. And I'm not going to initialize it right here, which we could, because I want to have this. I want to show using multi-dimensional or nested loops to make this happen. Okay. And I'm going to create. I'm going to do something actually even a little bit different as well. So I'm going to say the column size equals 4, so that we can make all of this dependent on that variable. Okay, it's a better way to do it. This way we can make the logic work for any size array. And I'm going to make a loop here that counts columns from 0 to column size. Okay. Now let's take a moment, reflect on what's going to go on in this loop. Or what is this going to do? Okay. Column is going to iterate. It's going to get initialized to 0, and it's going to count. It's the first time through, it's going to be 0, then 1, then 2, then 3, and then it's going to quit when it's equal to 4, right? So it's going to count 0, 1, 2, 3 inside that loop. Okay. I'll create another variable called counter that I'll initialize to 1, and then I could do the following. Okay. Now what's that going to do, right? It's going to initialize each cell of that one-dimensional array one at a time, right? First time through, it's going to initialize location 0 to 1, to value 1, right? And it's going to effectively give us this, right? Because column is going to count 0, 1, 2, 3, and as we're going into each location, we're going to write 1, 2, 3, 4. Okay. Now let's confirm that this actually works. Let's make sure we test it and run it. And I'm going to print the array out. And we can do that. We're going to iterate the array in a very similar way, except now I'm going to print it out. Okay. So we're just going to print the array out. Okay. So I'm going to compile it and run it. Let's make sure this works the way that we're expecting it to work. Okay. And indeed it does, right? We see 1, 2, 3, 4. We have one row. Okay. Now we're not done, right? We're not done because what we really want to do, and you can see my really well-behaved French Bulldog, Gus here. We're not done because what we want to do is we want this to work across not just one dimension, right, but for multiple dimensions. And what we could do now is we had a loop that did this for column. Okay, we could have another loop that iterates the rows. Okay. And effectively what we want to do is to have the loop do something like this, or the two loops together to count like this. Okay. And this is going to continue on. Right, I didn't do the whole thing out, but notice column's going to go to 0 to 3, right? Once that loop ends, it's going to increment row, and column's going to reset. Okay. Well, how do we do that? Okay. How we do that is we're going to wrap column inside of another loop, another for loop, and we want to keep this organized. So we're gonna increment this. We're gonna indent it so we could see the code block. We're gonna see that this is within that code block here, and we're gonna expand the logic up here. We're gonna say, hey, row size. I said the number of rows is gonna be 3. Okay, so then we're gonna do this. Okay. So that now we're declaring a 2-dimensional array. Okay. And think about it, right? Row is this if we trace how this works, row is going to be 0, right? Then column 0. Then in here, we're going to have to say the row. It's going to start at 0, 0, increment the counter, and it's going to increment. It's going to follow a pattern like this, right? Where the counter for the inner loop that's incrementing column is going to count up from 0 to 3. Then row will get incremented and column will reset, right? Because this loop will terminate, this inner loop will terminate, okay? It'll come back around, increment row, okay? And then it will reset column back down to 0, okay? Now, to get this, to be able to see this working, I'm gonna have to do the same thing down here, right? I'm gonna have to make sure that we're printing it out correctly. And I could do one other thing that's going to help me visualize it is I'm going to put a new line here after the inner loop completes. So this will go to the next line, right? Let me run it with that there, and then I'll show you again if it's not there. Okay. So notice this worked the way we're expecting, right? We have this nice table printing out, just as we talked about what our goal was. If I didn't have this here, right? This new line occurs after we're finished counting the end of the columns, right? We got when column gets to the column equals 3, right? Then when it goes to 4, the loop terminates. It then goes to the next line, right? The inner loop ends, goes up to the outer loop, right? So this is our outer loop. This is our inner loop. Okay, and if we didn't have this, it's going to print everything on the same line. Okay, it looks like a one-dimensional array there, which is effectively how it's stored in your computer's memory. But how we're going to think about it and use it is we've got the two coordinates, row and column, to be able to use it as a table or a matrix. Okay, if you had trouble following any of that logic, I highly recommend rewatching this video. But I'm going to stop it there, right? Because we're going to follow up. We're going to do a couple more exercises related to two-dimensional arrays in the next video, which will hopefully help solidify what's going on and how it works. Okay, and so we'll wrap it up at that point. But again, feel free to rewatch this video to clarify any misconceptions.